body use the food you consume? How does it take what you eat and turn that into running, jumping, swimming, and thinking? We all know that what we eat is ultimately what fuels our bodies, but eating is such a routine part of our lives that what actually happens to that food once it's inside of our systems kind of becomes really abstract and sometimes seems irrelevant. Nutrition is extremely complex and kind of really confusing. The internet is full of conflicting information about what we should and what we shouldn't consume. While one article will tell us the benefits of limiting our carb intake, another article will tell us the harms of doing so. Eating is something we do every day, and it's critical to our sheer existence, but most of us still don't have a clue of what the right answers are. This video is not going to tell you what you should or you shouldn't eat. I'm also confused by a lot of the information out there. Lately, I've been learning a little bit about how each of the different nutrients are used inside of our bodies. Though I already knew that all the macronutrients play an important role in a healthy body, digging just a little bit deeper into the specifics has helped me to actually understand a little bit better the importance of balance in a diet. So I'm gonna do my best to summarize a little bit of what I've been learning, so hopefully it will help you understand your body a little bit better as well. We'll start with carbohydrates. I'm going to focus a little bit more on these because they play such a massive role in our bodies, not only as athletes, but just as humans in general. Every single carb that you eat, whether it's an apple, a zucchini, barley, beer, whatever it is, will be broken down into a combination of what are called monosaccharides. These are simple sugars, and there are 3 different kinds. There's galactose, glucose, and fructose. Ultimately, once these are absorbed into the bloodstream, they'll be converted into glucose if they aren't already glucose. The liver is a super cool organ, and it's the one that's responsible for this conversion. Among athletes, it's fairly common knowledge that you need glucose to fuel your muscles, but everybody needs glucose all the time. We need it to think, we need it to move, we literally need it to do everything. I should also mention that our bodies are 100% efficient at absorbing monosaccharides, so the carbs that we choose to consume play a really big role in dictating how much glucose is in our blood. So we've eaten some fruit, chemical and mechanical digestion break down this fruit into monosaccharides, the monosaccharides are absorbed, and now glucose is floating around in our bloodstream. This glucose is now available to be used in several ways depending on what the body needs. The top priority for glucose is cellular respiration. Now don't worry, I'm not going to get all sciencey on you. Cellular respiration is a really complex multi-step process, but the main point is it produces ATP. ATP is a form of energy that our cells can actually use. You can think of glucose as maybe like a seed and ATP as fruit. So while the seed has a lot of potential, the fruit is what we can actually use. So if our cells need energy, the glucose in our blood heads on over to the cells to make some ATP. Glucose that isn't needed right away for ATP production can be used to make some types of amino acids, or it can be stored in our liver or in our skeletal muscle as glycogen for later use. We don't have a ton of space for glycogen, so any excess glucose that can't be stored this way is shipped to our adipose or fat tissue. The storage here is unlimited, so we can just keep building up our fat tissues forever. Fats are made up of glycerol and fatty acid chains, and they're stored in our bodies as triglycerides. Triglycerides are essential to our bodies. They contribute to important structures like cell membranes, which dictate what enters and what exits our cells, and other structures like myelin sheaths, which allow quick and efficient nerve impulse conduction. Not surprisingly, triglycerides are stored in our adipose tissue as fat deposits. When necessary, fats can be broken down into glycerol and fatty acid chains to contribute to cellular respiration, or they can be converted into glucose by the liver. The proteins we eat are broken down and absorbed by our bodies as amino acids. Amino acids are the tiny building blocks of protein. You can think of them kind of like little pieces of Lego, if you were made out of Lego. They come together to form enzymes, hormones, transporters, and other structural components of our cells. They're basically what our bodies are made out of, and they play a large role in how our cells function, so it's really important that our bodies get the amino acids that they need. There are a bunch of different types of amino acids, and like I mentioned before, glucose can actually be converted into some of those. The amino acids that we can make inside of our bodies from glucose are called non-essential amino acids. The amino acids that we need to get through our diet are called essential amino acids. Just like triglycerides, amino acids can be converted into glucose by the liver. So just to summarize, glucose is super necessary because it's a key ingredient in ATP production. It's also really versatile. With the help of the liver, glucose can be converted into triglycerides or amino acids. Triglycerides keep everything running smoothly, and they can be converted to glucose by the liver. Amino acids form proteins, and proteins are essentially what our bodies are built out of. Just like triglycerides, the liver can also convert amino acids into glucose. As you can see, the liver is a pretty crazy cool organ. It can convert glucose into anything and anything into glucose. Although the liver can make glucose from things that aren't already glucose, if we rely solely on fats and proteins for energy, that's a lot of pressure on the liver. That's also a lot of fat and protein dedicated to something that carbs can do a lot better. The fewer carbohydrates we consume, the more fat and protein our liver has to convert into glucose, which, yes, is awesome for fat burning, but that's only one side of it. While we'll have lots of triglycerides and amino acids dedicated to energy production, we'll have fewer that are dedicated to their actual roles, and our liver will be working overtime. Carbs, fat, and protein all work together, and we need to take in all three of these macronutrients in order to achieve a healthy balance. Each of the macronutrients is really good at what they do, so the more that we know about them, the more we can take advantage of that.